Hello class, Professor Anderson here. Let's take a look at an example problem that hopefully looks very familiar to you guys. And it's the following. A force F is applied to a mass, and that mass is going to accelerate at some particular value. We'll say it is 10 meters per second squared. And the question is, if I apply half the force, what is the new acceleration? Okay. And people don't like these primes very much because they think it means derivatives. So let's do this. We'll say the first acceleration is that, and we're going to calculate the second acceleration, A2. So, what do you guys think? Let's take a guess. Anybody have a guess what the answer should be? Yeah, Ian?
20.
Okay. Why do you think it should be 20?
Because of the equation for force is F equals ma.
Okay. All right, let's try it out. Ian said, let's guess that the new acceleration is going to be 20 meters per second squared. All right, let's see what happens. F equals ma. Specifically, this, right? The net force equals the mass times the acceleration. In this case, we only have one force, so we can just write F equals ma1. That's the first condition. And now the second condition is, let's say that the force, we'll call it F2, goes to half of what it was, half of F1. Okay. What is this new acceleration? Well, we still have the exact same equation. Sum of the forces equals mass times acceleration, but now we have a different F2 and we have a different A2. And what we just said was F2 is really F1 over 2. And we want to calculate A2. All right, but we know exactly what F1 is, right? F1 is equal to ma1. And so I can stick that into this equation right here. And I get ma1 over 2 equals ma2. And we can cross out the m's, and we get A2 equals A1 over 2. Our A1 was 10. 10 over 2 is 5. Okay. So we got 5. You're right that it's a linear relationship between acceleration and force. We just went the wrong way, right? We doubled it instead of cutting it down by a factor of 2. And that should make sense to you, right? If I push on something only half as hard, it can't accelerate as fast, right? So in this case, we cut our force down by a factor of 2. Acceleration got cut down by a factor of 2. Okay, let's modify some other parameters and see what happens. Here, let's take a look at an example problem where we apply a force to a mass and it accelerates at A. And then we are going to cut the mass in half. So this is M1, F1, A1, and now we're going to say that M2 is half of the mass that it was before. We're going to apply the same force and we are going to figure out what this new acceleration is. So, if I cut the mass in half, what do you think? Should it accelerate more or less? And if so, what's that number? Anybody have a guess? Yeah, Ryan, what do you think? What's your guess?
It should do more. It should actually double it.
Okay, smaller mass seems like it should be easier to accelerate, right? That makes sense to me, right? If I try to push a bowling ball versus a soccer ball, it's much easier to get the soccer ball moving with the same force. So you think it's going to cut it in half? Is that what you said?
Double it.
Double it. Very good. So let's see how to work this out. Okay, the first case, sum of the forces equals the mass times the acceleration. I've only got one force, F1. It's equal to M1 times A1. Good. In the second case, now we have F2 is equal to M2 A2, but I know what some of these things are. This is the same as F1. M2 is the same as M1 over 2. And now we can solve this equation for A2. What do I get? A2 equals 2F1 over M1. But I know M1 and F1 are tied together in that first equation. So I get 2 times M1 A1 over M1. M1's cancel out. I get 2A1, and that is exactly what we guessed. It shouldn't be 10 meters per second squared. It should be 20 meters per second squared. Good. So our guess was right on the money, and our intuition was correct. If you're pushing something lighter, it's going to accelerate much more quickly. All right, let's try one more where we cut down both the force and the mass. Here, let's look at this force problem again. We had a force F1 acting on M1, and it accelerated that particle at 10 meters per second squared. And now we're going to cut the force in half, but we're also going to cut the mass in half. And we want to figure out the new acceleration. So, what's your name, Mai, in the front? Mai, what's your guess? What's going to happen if I cut both of those down? What's going to be our new acceleration?
Just by looking at it without any math, I would say the acceleration stays the same because if it's exactly half, then it doesn't really alter.
Okay, so our guess is 10 meters per second squared. All right, let's see if that works out. The first case, we have sum of the forces equals mass times acceleration again. F1 equals M1 A1. And now in the second case, we have F2 equals M2 A2, but I know what those are. This is F1 over 2. This is M1 over 2. And now look what happens. I can cross out the 2's, multiply left and right by 2 and get rid of those halves. And I get A2 equals F1 over M1, but that's given by this, M1, A1 over M1. Cross out the M1s, and we were right on the money. It is 10 meters per second squared, doesn't change. Okay, so if I take an object and it's half the mass, but I push on it half as hard, it still accelerates with the exact same number. All right, good. Any questions about this stuff? Is that pretty clear? Okay, you can think about these intuitively. This is how you do it strictly mathematically.